Another beautiful day of AP Calculus. Say hi, Stego. We miss you. By the way, we signed up for the AP Calculus test online, so remember to do that when you come back. Today's date is Thursday, October 10/10/19. We're talking about curve sketching today. Today is our last day of doing graphical analysis, so if we come back here and look at our unit guide, we are on our last day of graphical analysis, and then we go to analytic analysis where we don't have any graphs anymore, just pure functions. We'll have 3 days of that, and then self-checks, pre-test, fix-up, test, like we normally do. There were some errors on the key. Hopefully you can find those too. I think Claire found 2 of them in terms of square brackets and CVs. All right, objective today. Someone read it.
Sketch the graph of f prime and f double prime given the graph of f.
There it is. That's it. It sounds like an easy objective, but because you need to have everything down for the previous unit 3-1 through 4, it does make it kind of hard. So let's go ahead and graph x squared. You guys know how to graph x squared? Do it now. I'll see. Haha. You guys are indeed correct. You should have its vertex, its most bottom point, the origin, and then if I plug in x equals 1, the x coordinate 1 squared is 1. If I plug in the x coordinate 2 squared is 4. 1, 2, 3, 4. And then you have this axis of symmetry, which means it's the same stuff on the left-hand side. And go ahead and make a sketch. It should be roundish towards the bottom, not a V shape, although my graph is so small that it's hard to tell that. Arrows going up forever and ever. If I go to the left towards infinity, it does go towards positive infinity for the height. If I go right towards infinity, it goes positive infinity as well. So when I take the derivative, just analytically without any graph, if I have x squared, take its derivative and write it here. All right, Gio, what are you writing down? You got x squared, the derivative is? Derivative of x squared.
2x.
There it is, 2x. So graph 2x. What does 2x look like? And hopefully, let's see, chunk chunk right there. Hopefully you're graphing something similar to Mr. Sindel, where it goes through the origin again, and then it goes right one up 1, or right one up 2, right one up 2, and it goes left one down 2, left one down 2 to get those points, at those lattice points. Everyone can graph that okay? We're good, we're Gucci, we know what we're doing. And take a moment to realize what's happening here. So we had our f minimum here. This was an f minimum, a function minimum. Why? What is the definition of f minimum? Is it f prime or f double prime, first of all? What is the definition of f minimum? F prime. F prime is what? No, take another guess. That's relative extrema. For an f minimum, though, it goes from, f prime changes from a negative to a positive. So this is f prime goes from a negative to a positive. And look at that. F prime on a graph of f is what? Height, slope, or concavity. What is f prime on a graph of f? Height, slope, or concavity? It is indeed slope. So the slope should go from a negative to a positive. And check it out. The slope is negative. Slope is positive. Where does the change occur? Right here at the CV at 0. That is where I have an f minimum. It's also an FCV. And that's all we've got. All right, coming back to this graph of f prime. What is f prime on the graph of f prime? Height. So we're going to say f prime height. And what is the definition of f minimum without looking at your notes?
Negative to positive.
What changes from a negative to a positive? F prime or f double prime?
Prime.
Yes, f prime changes from a negative to a positive. We have the definition written right here. And check it out. The height should go from a negative to a positive. The height was negative. It went to a positive. Where did that change occur? Right here. We know that that is an f minimum. It's also an FCV. Why? What is the definition of FCV, Arrow?
F prime sign change.
That's a relative extrema, which it is.
F prime equals 0 or does not exist.
Nope,
No.
that's an FCV. Oh yeah, sorry, that is
Wait.
FCV. You're right.
What?
That is an FCV.
No, that's an FCV.
F prime equals 0 or DNE, or DNE. And Arrow was also correct in saying it is a F relative extrema as well. F relative extrema. It is all of those things. Just getting some review in here. So what's going to happen algebraically, analytically, without looking at the graph when I take the derivative of 2x?
It's just gonna be F double.
2, write it down.
So it's gonna be yes.
And graph that horizontal line that goes through y, the height of 2. Graph it now. You should have a line that looks roughly like that. Do you have any ability to check where F minimum is?
No.
Why?
Because there's no X. It's just like because it's the concavity, not the
So
plane.
to give you the answer, what is the definition of F minimum? What goes from positive to a negative? Or sorry, negative to a positive? F prime, F double prime? F prime. What does F prime look like on a graph of F double prime?
It doesn't exist.
You can't see it. You have to go backwards from height, and technically that's area underneath the curve, but you haven't figured that out yet because we haven't done unit 5. So we can't do it. Can't do it. So we can't figure out where our F relative extremum are, where our FCV is, where our F minimum is. We can't see it on a graph of F double prime. Let's go ahead and just take the derivative yet again. When I take the derivative of 2, it turns into 0. There it is, 0. Graph that. What does that look like? There it is. And again, you can't look at F prime because we are way too deep. We've gone all the way into the, what do they call it in inception? It's hard to say. I think they call it limbo. We've hit limbo. We've gone so far that we can't even see back up. Okay, this is the main point that I want you to take away from this section. What type of function turned into what type of function? So what do I call this thing? It starts with a Q. What type of function do I call it? Say again?
Quadratic.
Quadratic. You don't need to know this word for the AP test, but it is important to know the pattern. I have something with a curve in it. And then what I call this function that looks like a line. Linear. This one is, you could call it linear, but there's a more specific function called something with a C. Does anyone know it?
Constant?
It is a constant. And I guess I can only call this constant as well. A constant of 0. I guess a more formal, I think constant is the most formal you can get. You could call it the 0 function as well. So notice what happened. Was this a positive quadratic or a negative quadratic? So write it down underneath. This was a positive quadratic. Was this a positive linear or a negative linear? Positive linear. Was this a positive constant or a negative constant? Notice that the sign always stays the same throughout the graphs. If I had a negative quadratic, I should have a negative linear, which means you have a negative slope, like -2, or a negative constant, which means your height is negative. I have a -2, and then, of course, you go back to 0 depending on where you started, which is neither positive nor negative. So check that out. Quadratic to linear to constant, positive to positive to positive. These patterns will emerge. You will use these patterns in order to help you sketch a curve. All right, so here's a graph of G. I need you to graph a graph of G prime. So go for it right now. I'll let you play with it. Again, it's purely sketch because there's no, I didn't give you an x-coordinate of 2. It happens right here. Just give me a rough sketch. Go for it. All right, I think every single one of you got it. So what type of function is this in terms of these terms that we were writing down? What do I call this thing? A negative linear. Perfect. Which means when I take the derivative, I should have a negative constant. There it is. So I'm going to guess that this slope is about -1 if it was to scale. But maybe this was a height of 2 and this was a height of 10. You don't know if it's to scale. I didn't say anything. So all we can do is just make it a negative constant down here. Yoink. There it is. And I mean, we should have arrows in America. We just had this conversation that Claire got yelled at for not having her arrows. That should have arrows as well.
For
But whatever.
having arrows, not for not having them, for having them.
Yeah, she got yelled at for having them when she went to Germany.
Which is an interesting thing.
All right, so for example 2, ooh, this one's going to be shifted a little bit. So notice that your vertex is over here. with that in mind, what does your graph of h prime look like? Go for it. All right, the hint that I always love to give students on this one is what is the x-coordinate of your f minimum? So right here, I have an x-coordinate where my f minimum occurs. This is in my f minimum. So your x-coordinate for your f minimum should happen over here. On a graph of h prime is height, which means my height should go through 0 at the same x-coordinate. If I have, what type of function is this? Is it a positive, negative?
Positive.
Say positive, quadratic.
Yes, sir.
So it should be a positive linear. And it should go through the same x-coordinate as your f minimum, so our line should be a positive. Oh yeah, sure, if it wants to have a slope of 1, I don't care. There it is. It's a positive linear that goes through that same x-coordinate. If you did a line over here, well, that was really straight for just having a pencil. That is incorrect because you need to make sure that your f minimum happens at the same x-coordinate as your f minimum on your graph of h. So far, so good? All right, example number 3. Ooh, what do we call this thing? This is a good review of Algebra 1. My Algebra 1 students and my current geometry students, since I did it last year, have this down pat.
I haven't taken Algebra 1 in 5 years. No.
What is this thing called? It's not a sine wave, by the way. This goes down and down forever. It doesn't come back up like a sine wave. What type of function is this called? You don't need to know it, of course, for AP Calculus.
I don't know what it is. It's a 1-up quadratic.
A 1-up quadratic,
Is it
if
called
I,
that?
it's
Can I-
called a cubic.
Oh,
Right,
that seems obvious.
cute.
Is the other one called a quartic?
The next one is called a quartic. So cubic, and the question that I have for you guys is it a positive or a negative cubic?
Negative.
It's a negative cube.
Why?
Wait.
It goes down,
where's
but then
the
it goes
dance?
up.
Oh,
Where's
yeah,
the
the
dance?
dance.
Hold
Yeah,
on.
remember your dance.
Hold on, I don't remember it.
Positive even.
What's positive odd?
Positive odd.
Positive odd is your right hand up. Positive odd. So this is not a positive odd, it's a
That's negative.
Negative.
negative odd. Perfect. Your right hand is usually the one that'll tell you if it's positive or negative. If your right hand, our right hand is down here, it's negative. Therefore, this is a negative
Forget
cubic.
which hand is your right hand. That's pretty common.
That
Right
is
hand.
not that common, but
It's
It
sort
is.
of common.
it is common for like
Bend
tinier.
and arrow all have
Really? Oh.
Yeah, no, every
Directional
time I try to give
disability.
someone directions in a car,
I literally go
everyone-
like this.
Notice where your x-coordinates are for your relative extremum. You have a relative extremum here and here. What does that tell you about your graph of J prime? I'll let you figure it out. Good luck. All right, so if I have a negative cubic, it should turn into a
Negative quadratic.
negative quadratic. And if you forgot what a quadratic is, it's up here. It's this U shape. That is a quadratic. This is also a quadratic. So a negative quadratic, it is a rainbow. Or if you prefer to be depressed, it's a sad face. At the same x-coordinates, I should have relative extremum. And it is a relative extremum because it changes signs. I have a change of a slope, which means I should now have a change of a height. So a change of height means I go through the x-axis, and since it's a negative quadratic, it needs to be a rainbow. Whoop, right through there. Also, what is this point? What do I call this? These are extremum, so I'm going to call it
That's
relative
the IP.
extremum, relative extremum. And that, again, Claire has it. It's the inflection point, which means our inflection point should have been, yeah, my graph wasn't the best over here. Can I try that one again? Is it going to delete both of them? Whatever. That means I should go have a flat or a slope of 0 at that x-coordinate. Come on, Mr. Smith. Okay, so the way that I figured out that makes this, if you just keep doing a bunch of little lines, then it makes it easier.
I think the second point is way too far out
Yeah,
there.
it is. Aren't
That's
they supposed
the
to be
problem.
equal distant from the?
They are. So that was the reason I'm making mistakes. Here, let's make this a little bit closer. Hey, now I can come down and make it look. Ah!
Oh, it's too close.
No, it's fine.
Kind of.
There it is.
Kind of fine.
A negative quadratic, where I have an inflection point at this x-coordinate and I have relative extremum at these coordinates. All right. This bad boy. First of all, is it even or odd?
Even.
It's even. Is it positive even or positive odd?
Positive even.
So it's a positive
This.
even, and its actual name is
Wait,
quartic.
how do we know if it's even?
Ooh, good question. How do we know?
Dance. Positive even.
Both of them
Positive
are
even. And this is end behavior, by the way. positive even, negative even.
Oh, and
Positive,
then these
positive
are
odd,
odds.
because I'm doing it in the mirror now.
Okay.
Positive even. There it is. So this is positive even. If you want to know the name, you don't need it. It's quartic. It is positive even, technically a positive quartic. Ooh, so how is this going to work for its graph of the derivative? And this refers all the way back to notes 3-3. Every time that I take a derivative, I lose a curve, or I lose a change of direction. I change directions once, twice, so this one only changes direction once.
So it has to go like both line up like that, or?
Okay, so if I'm taking the derivative,
You can't change the sign, right?
hold on. So if I can't change the sign, so if it's positive even, it should now be positive odd. And if it was positive quartic, it should go to positive, wait, did I say quartic?
You
Yeah.
also intercept the
Odd,
Yeah.
odd cubic. And the next one after quartic is quintic, but again, you don't need to know that.
And how did you do it? Odd is like this, right?
Yep. And make sure it's positive, so your right hand should have been up.
It's like that.
There it is, yeah.
Okay.
All right. All right, so the way that I start this one is obviously figuring out it's even quartic, and it's going to go to odd cubic. Both of them are positive. So if they're both positive, that means my right hand should be raised, my right hand should be raised. So I know that I'm going to have something that starts in this vicinity. From there, I'm going to go ahead and identify the x-coordinates of the relative extremum. Relative extremum means I'm having a change of slope here or a change of height here. I'm going through the x-axis on the graph of the derivative. So my x-coordinates are here, here, and here. And I'm going to mark those same x-coordinates over here, here, and here. So that means I'm only allowed to go through the x-axis through those points. I can't go through over here. I have to go through those points. And I know I start up here. If you want to be very, very, very accurate, you don't need to for this graph because it's so evenly distributed. But I would also do the x-coordinates of the inflection points, which are kind of hard to figure out, but I am concave up here and concave down here. So my inflection point is roughly right here. My inflection point is roughly right here. So the x-coordinate are here and here. X-coordinate, again, are exactly halfway in between, it looks like, here and here. Which means that I should have a change of slope instead of a change of concavity on this graph.
Most of the time, isn't the IP like exactly halfway?
Most of the time it's not actually. Well, if you're only on the AP test, I would agree with you, but in general, no. There's just so many types of functions. I might have lied to you, but that's my personal feeling. It's not mathematically backed though in any way. All right, so I have to start up here. So I'm starting up here since it's positive. Positive starts up here, negative starts down here. So positive, it comes down, it comes through this point, and then it needs to come back through this point in the other direction so I can make that. And then it's going to come back through this point, and I just need to connect them. So this is going to be a slope of 0 there, a slope of 0 there, and then it goes down and down and down and down. There is my graph. And it is a cubic because that matches my end behavior for my dance. Woo! And make sure that you know that this is a slope of 0, passes through there. Those are relative extremum. We're good. You guys think you got it? All right, let's try for the homework.